Hello everyone, and how are you all today? Today it is my goal that we will at least complete exercise 1C so that we can move forward with other exercises. Okay, so let's start. Today we need to start question number 8 of exercise 1C. Alright, we have done similar questions already. Let's go through this question as well. Z is inversely proportional to X. 1 point, remember. In inverse proportion, we will straight multiply, not cross multiply. That's in direct proportion. Okay, so Z is inversely proportional. Z is equal to 5 when X is equal to 7. So 5, 7. What is the value of X when Z is equal to 70? So this is 70, and over here we will write X. Again, as I told you, we will straight multiply. So we will multiply 7 with 5 and we will multiply 70 with X. Alright. So 7 multiplied by 5 will be 35. So this will be 35 is equal to 70X. And then the 70 will go over there. So 35 divided by 70, that is 1 upon 2. So that means the value of X will be 1 upon 2. And hence this question is done. Now question number 9. If B is inversely proportional to A and B is equal to 3.5 and A is equal to 2, find the value of B when A is equal to 14. So when A is equal to 1.4. So I want you all to try this question yourself and then you can evaluate with the help of video. Alright, now let's solve this question together. So A is inversely proportional to B. When B is equal to 3.5, A is 2. So A is 2 and B is 3.5. Alright. Find the value of B when A is equal to 1.4. So we will put 1.4 here and B. Let's leave B as B. Now again we will straight multiply. Alright, so we are multiplying 2 with 3.5. That will be 7. 2 multiplied by 3.5 is 7. So this will be 7. 1.4b. Now 7 divided by 1.4. Now can you tell me what is 7 divided by 1.4? Yes, 7 divided by 1.4 is 5. So B will be 5. So the value of B is 5. Alright. Now let's do question number 10. Let me take this table here. Yes. For each of the following, Y is inversely proportional to X. Copy and complete the table. Now, if I see this first table, okay, we are seeing this first table, we should find the value of K. Okay, so let's figure out the value of K first. So we have these values complete. So we can easily figure out the value of K. What is K? Since the equation for inverse proportion is Y is equal to K upon X, so K will be YX. So Y value is 4 and X value is 3. So 4 multiplied by 3 will be 12. So the K value is 12. So Y is equal to K upon X. This is our equation. Y is equal to K upon X. Now, Y is 24. And K is 12. So we will do 12 divided by 24 to find X. So X is half. That is 0.5. Then over here, when X is 2, so since K is 12 actually, so 12 divided by 2 will give me 6. Then X is 2.5. So 12 divided by 2.5 will give me, yes, 12 divided by 2.5 will be 4.8. So the answer is 4.8. Okay, and then coming to this one, now my Y value is 1.5. So over here, I'll place 1.5 and this will be 12 divided by 1.5 to find X. So what is 12 divided by 1.5? That is 8. So my answer will be 8. Now we will look at the next table. Now this is the next table. I want you all to try it yourself. So what will be the K value? Yes, the K value will be 36. Alright. And then our equation will be Y is equal to y is equal to 36 upon x. Alright, now this x value will come over here. So 36 divided by 3. What is 36 divided by 3? That is 12. So y value will be 12 over here. Then 8. So we will again do 36 divided by 8 in order to find x. So this will be 4.5. Then 36 divided by 2.5. What is 36 divided by 2.5? That is 14.4. And then finally 36 divided by 25. That is 1.44. So even this table is complete. Alright, I'm sorry, 36 divided by 2.5 is 14.4. So this will be 14.4, not 14.5. So now we've completed this question. Let's move towards the next question. So question number 11. The frequency f kilohertz of a radio wave is inversely proportional to its wavelength. The frequency of a radio wave that has a wavelength of 3000 meters, 100 kilohertz. Okay? So that means we will multiply these two quantities to find our constant ratio or the constant k. So 3000 multiplied by 100. This will give me 300,000. Right? Find the frequency of a radio wave that has a wavelength of 500 meters. Alright, so first let's make the formula. So frequency is equal to, this is the k value, 300,000 upon wavelength. Okay, so let's write this as W. Okay, now it says the frequency of a radio wave that has a wavelength of 500. So I'll put 500 over here. So this will be 300,000 divided by 500. Okay, 300,000 divided by 500. Oh, okay, so these zeros will get cancelled. And what is 300,000 divided by 500? That is 600. So our frequency will be 600 kilohertz. Perfect. Now the wavelength of a radio wave that has a frequency of 800. So we will put frequency over here. 800 is equal to 300,000 divided by wavelength. And then 300,000 divided by 800. So what is 300,000 divided by 800? That is 375. So my wavelength will be 375 meters. So we have also done this question. Alright, now let's look at question number 12. The time t hours needed to complete a job is inversely proportional to n, where n is the number of men employed for the job. 3 men can complete the job in 8 hours. So my k will be easy. 3 multiplied by 8 is equal to 24. Find an equation connecting t and n. So the equation will be basically t is equal to k upon n. So if the k is 24, so the equation will be t is equal to 24 upon n. This is my equation. Find the number of hours needed by 6 men to complete the job. Now over here my men will be 6. So 24 divided by 6, t is equal to 24 divided by 6. Now what is 24 divided by 6? That is 4. So the time will be 4 hours. Then if the job is to complete in 3 upon 4 hours, that means 0.75 hours, 3/4 hours, how many men need to do the how many men need to be employed? So how many men are needed for the job basically? We'll use the same formula. This time we have the time. So it will be 3 upon 4 is equal to 24 divided by n. We don't know n. So we will cross multiply. 3 upon 4 is equal to 24 upon n. So this will be 3n is equal to 24 multiplied by 4. And this 3 will go over there. So 24 divided by 3 will be 8. 8 fours are 32. So my number of men I need to employ will be 32. And hence we have also completed